Now we have to prove why it is called as fast adder, right? Why it is called as fast adder? Now you have to understand the delay calculations first, that, right? Listen. So for delay calculation, this is a full adder. If you take any full adder, right, this is the gates which is used, right? In order to produce sum, how many delays you need? You have only one gate, right? So for producing sum, you need only one gate, one delay here, correct? And for carry, what you need? You need an AND operation here. This can be done in one clock cycle. That is parallelly it will be done. So that this is for one delay and this is another delay, right? So for carry, it is equal to 2, right? So if you take any full adder, understand very carefully. If you take any full adder, the delay for carry is 2, right? And the delay for sum is 1. Okay. Now I will go to ripple carry adder, right? So that I can explain why carry lookup adder is faster when compared to ripple carry adder, right? Remember, for producing sum you need 1, and for producing carry you need 2 delays, right? In full adder. Now we are using 4 full adders in ripple carry adder, right? Now for this, right, S3 and C3, right? What will be the delays? Listen. So for carry, for each full adder I will take 2 delays. So for this one 2 delay, this one 2 delay, this one 2 delay, and this one 2 delay, right? So which means 2, 4, 6, 8. Got it? So carry is 8 for ripple carry adder, for 4-bit ripple carry adder, 4-bit ripple carry adder, right? Carry delay is 8. And what is the sum? Sum is S3 here, right? So S3. So if it is S3, how it works? You need to have 3 inputs, right? A, B, and C2. This is enough, right? And you don't want to worry about the C3, right? So until here, what is the delay for carry? 2, 4, 6, right? Till here 6, right? And for sum, you will have 1 delay, correct? So it is 1. So 6 plus 1, 7, right? Sir, you said that it will only 1 for this particular sum, for this particular adder, you need only 1, correct? Right? For this adder to work, for S3 has to produce the result, it needs C2, right? In order to generate C2, how many delays you need? 2, 4, 6. So 6 delay for generating C2 and 1 delay for sum. So totally sum here is 7, right? Now understand this very carefully, okay? So for ripple carry adder, C is equal to 8 and S is equal to 7. The delay for carry is 8 and delay for sum is 7, right? We can write this in an expression, right? That is here, right? For sum, what you can do, this is a 4-bit adder. This is a 4-bit adder. For 4-bit adder, carry is 2 times the n, right? That is, the delay is 2n, right? And for sum is 2n minus 1, correct? Right? It is 4-bit here, and for producing carry delay, it needs 2 into n, that is 8 delay. It generates carry after 8 delays, and here it generates sum after 7 delays. Clear with this? Right? So for 4-bit ripple carry adder, you need carry 8 and sum as 7, right? And now come to the carry look ahead adder. Okay? Now carry look ahead adder. Understand very carefully. This is the point where we are explaining why carry look ahead adder is better when compared to the ripple carry adder. Okay, now you understand for ripple carry adder, delay for carry is 8 and sum is 7, correct? Okay, now you calculate the delay for carry look ahead adder. Okay, now listen, right? For generating the carry, how will you generate? Listen this expression. You can generate the carry only if you can calculate GI, PI, right? You need to find out GI, PI first, and then there is some other and OR operation. You can see this is P1, P0. This is an AND operation, and this is an OR operation. Correct? Right? So you have to understand here, right? There is an AND operation 1, there is an OR operation, so the 2 delays, and apart from that, you need to generate GI and PI, right? So here for carry look ahead adder, in order to generate the carry, right, this carry, remember you have to generate one, right, for GA and PA, one for GA and PA, another two for carry look ahead logic. What is carry look ahead logic? You go to this expression. In this expression you have AND gate and OR gate all this combined, right? So you need, for that logic you need 2. So totally carry will be 3, right, for one particular cycle. That is the first cycle, first cell, you need 3, right? And what is the sum? What is the sum? You can see C in is given here, right? And for C in, that is for the C, we need 3 delays, and for sum it is 1. So totally for sum, generation of sum, you need 4 delays for one particular cell. Hope you are clear with this, right? So you need 3 delays and 4 1, right? So now you understand how the delay for carry look ahead adder is calculated, right? C is equal to 3 and S is equal to 4. For generating carry, you need 3 delays, and for sum, 3 plus 1 is 4, okay? And very important point is, only for the first adder, right? Only for the first adder, you need 3 delays for carry. And apart from that, you need only 2 delays, because GI and PI is calculated only once, right? Only for the first time you will generate GI and PI, and apart from that, then you don't need to generate GI and PI every time, because you use the same value, right? So only for the first adder, right, you need 3 delays, and after that you need only 2 delays, okay? This is for generating carry 2, and for this full adder 2, and this full adder 2, and this full adder 2, correct? Got it? Right. Now understand one concept very clearly, right? Now we need to explain why carry look ahead adder is better when compared to ripple carry adder, right? And as I said before, right, I'll put a calculation here, right? In ripple carry adder, right, C is equal to, right, 2 to the n, right? That is, for 4 bit it generated 8, so it is 2 to the power n, 2 into n, right? And for sum it produces 7, right? That is 2n minus 1, correct? Now consider, right, what I have said, for carry look ahead adder, carry is 3 delay and sum is equal to 4, and only for the first one it is 3, right? And apart from that it is 2, right? Now consider, if you are going to implement a 32-bit adder, okay? That is, if you are going to implement 32-bit ripple carry adder, if you are going to implement 32-bit ripple carry adder, right, and here I am going to implement carry look ahead adder, which is nothing but a fast adder, okay? The calculation is very simple. If you are going to implement 32-bit ripple carry adder, so what is the carry? It is 2 into n, so it needs 64 delays, correct? And sum is equal to 2n minus 1, which will be 63 delays, right? Right. Now, if I am going to use the same, if I am going to implement using fast adder, if I am going to implement 32-bit fast adder, what will happen? Right. For 32-bit fast adder, what you have to do? Right. You have to, right, this is 4-bit carry look ahead adder. This is 4-bit. So the output is C4. Like this, you have to connect 8 4-bit ripple carry adder, right? So only if you connect 8 4-bit ripple carry adder, you can generate 32-bit, right? So first ripple carry adder, the first carry look ahead adder will generate the output C4, and the second one will generate C8, and the third one will generate C12, and next one will generate C16, right? That is 4-bit carry look ahead adder, and C20, and then C24, and then C28, and then C32. Got it? Right? Now understand, only for the first carry, first adder, right? Only for the first one, what will happen is, I'll generate 3 for carry, right? 3 for carry, another one is 2. Apart from that, everything is 2, right? 2, right? Now consider this one, 1, 2, 3, 4, 5, 6, right? 6 and 7. So totally 7 into 2, plus 3, correct? 7 into 2 is nothing, 14 plus 3, 17, correct? So for carry, it needs 17, correct? Right. Similarly, for sum, right? What is sum? Sum, right? If it is sum, what I have to do? That is this one. You can understand. That is just one bit extra, correct? That is 17 plus 1. So it is 18, correct? Now listen very carefully. If you're going to implement 32-bit triple carry adder, to generate the carry, you need 64 delay. And for sum, you need 63 delay, right? But if you're going to use fast adder, the delay is only 17 for carry and 18 for sum. And that is why this is called fast adder, right? Carry look ahead adder is a fast adder, right? So hope you understand the concept clearly, right? So today what we have seen is, we have seen what is carry look ahead adder, right? And what is the logic behind it, right? We have explained how the carry look ahead logic is generated, right? And then what we have seen is, we have seen what is the delay calculation between triple carry adder and carry look ahead adder. Why carry look ahead adder is slower and why carry look ahead adder is faster when compared to triple carry adder, right? Only if you understand the logic, you can able to explain. Okay? Thank you, students.
Thank you, students. Thank you for watching. கண்டிப்பாக இந்த வீடியோ உங்களுக்கு எல்லாருக்கும் ரொம்ப யூஸ்ஃபுல்லாக இருக்கும் நம்புகிறேன். Subscribe Passionate Professor and keep learning. Thank you very much.